We are moving our focus to LangChain now, which is my favorite framework for building AI applications. And there are two main reasons for that. The first one, it is because it is vendor agnostic. So it's super easy to move an application that is using, for example, Mistral AI to Anthropic, the other way around, use OpenAI. You just need to change one line of code in your LangChain application. The second one is that LangChain is not only a wrapper for an API, which was automatically built by some software. Here it was really built from the ground up on purpose. So it is highly efficient, and you will see that the syntax is also very consistent. So once you learn a few basics of LangChain, it's super easy to learn new functionalities thanks to this consistency. So whenever I build an AI application and I don't need a very specialized endpoint from Mistral like conversations and agents, I usually use LangChain. You will need to install LangChain, this main framework, and I just wrote, be sure that you have at least version 1.0 because they completely rebuilt it recently. Now this is built on LangGraph. And you will also need to install the package from your favorite LLM provider. So you see that you've got LangChain -OpenAI -Anthropic Mistral AI and so on. So they really support all the main vendors, and you will need to install it to be able to communicate with the different models. So here, in that case, I've already installed in my virtual environment. So the main one, LangChain, then I chose LangChain Mistral AI, LangChain OpenAI, and I've also installed LangChain Ollama for a local model. And as usual, I also installed python.env to manage my environment variables. So the main change, if we compare to what we did so far on this channel for Mistral AI, is that we are not going to create a client for the entire LangChain ecosystem. So before we used to create a client, a Mistral client that could help us communicate with chat completion, embeddings, conversations, agents, and all the Mistral services. So we don't do it at this vendor level. With LangChain, we will create at the functionality level. So we'll need a client for chat completion, one for embeddings, and one for the different other functionalities that you want to work with. I've created in this table a summary of the main ones that you can use for a chat application. For example, if you want to use OpenAI, so you need to install this package, LangChain -OpenAI, and to save your API key in this environment variable. If you use these standard naming conventions, you will not need to load your environment variable in your project manually. LangChain will automatically look for this name and load it in your application. So it has some benefits to follow this naming convention. And here there is a link where you can find all the providers. There are really many on LangChain. So let's start by just, at least I will load the environment variables. So I don't need then to extract a specific one, but I will load it. I created a .env file as usual with all my environment variables, all my API keys. And of course, I will not show you my keys, but here is an example file, how you can create it. Depending on the vendor you want to use, you will format your file this way and then just paste your different API keys here. And make sure that you name your file .env and you don't keep this dash example. And after that, I'm creating two LLM clients. So I use one for Mistral and one for OpenAI, so I can show you how you easily switch between the two. So here I took from LangChain Mistral AI the chat Mistral AI, and from LangChain OpenAI chat OpenAI. Notice that unlike the packages, when you install them, it's not a dash, but this is an underscore when you import the package, as usual in Python. So then you can use these different classes, and you can just provide a model name that you want to use, and that's it to create your LLM client. So here for Mistral AI, I'm using Mistral Small latest, and for OpenAI, I'm using the GPT-4o model. After that, you can use your client.invoke, and you can either pass a string, or as usual, you can also provide a list of messages. So this type of dictionaries where you provide both the role, which is user, the content, which is whatever prompt you want to send to the LLM. If you pass just a string, it will assume that this is a user message by default. Here I execute it, and you see that in return I get a so-called AI message from a LangChain. Within the content I can see the response from the model. If I want to do it with OpenAI, I just need to use the different client, but you see that the method is the same. So this is part of this consistency that I mentioned at the beginning. You will always have the same type of method for the different clients, whatever vendor you chose. And also you will see that for a lot of functionalities from LangChain, they call those some runnable, and you will always have some consistent methods like invoke. You will see it across a lot of functionalities. And here I get the response this time from OpenAI. It also supports streaming, which means if you want to display the text as it's being generated and you don't want to wait for the full response to be ready before it is displayed, in that case you don't use .invoke, but you use .stream. And you need to then loop through this stream. So as soon as a chunk of this response is available, then you can display it with this chunk.content. Make sure that you use these two parameters in your print statement. So end is an empty string to make sure that it does not include unnecessary line breaks. And flush is true will also allow you to display as soon as it is available. Otherwise, sometimes, especially in the Jupyter notebooks, it can have some kind of a buffer, some waiting time before it is displayed. So here, if I do it, we should see that, as what we are used to with a web interface like ChatGPT, we see the text while it is being generated, which can be a good feature if you create a chat application. This is something that more and more users expect nowadays. And finally, to close this first video about just the chat model clients, you can also run a local model if you use Ollama. So I've already created and published a video about Ollama and how to use it with Mistral AI, but you can also use it within LangChain. So you need to install first the package LangChain-Ollama and import it with LangChain_Ollama, and you've got this chat Ollama client that you can use. So as usual, you create a variable to assign your client to it, chat Ollama, and you provide a model name. And of course, in that case, you don't even need an API key because this is a local model. So I will just go to my terminal. I will create a new instance. And let's check if Ollama is running at the moment. So I will check what are my different models. So I've got Gemma 4 and I've got Mistral, and I think by default it will also run Ollama. So if I type serve, it should tell me that, yeah, it's already running, fine. So now let's go back to the code and let's try. So I chose this one, Gemma 4, and let's try again the single prompt. And it may take some time for the first one at least. Also, this is a fairly large model for my laptop. But you see that at least you have this consistency across the different vendors, whether you use a cloud model or a local model, if you use one from Mistral, OpenAI, or even here from Google. This is always the same method that you will use .invoke. In the next video, I will show you a bit more how you can work with the different type of messages, the user messages, assistant, system, and so on, and what are some very interesting functionalities that are linked to these classes. We will also create a first chain before we move to the tools and the agent. So I see you in the next video. Bye bye.